if I want I have any number that is base 2 and I want to convert that into base 10. You can call it either a Denary number, you can call it either a decimal number, that's totally up to you. I just mean to say that if you have a binary number and you want to convert it into a binary number, into a Denary number. So if it's a binary number, that means that it is going to be base 2, and if it is binary, that means that you are only going to store two values right here. Like for example, 11000011. This is an example of an 8-bit binary number, right? Uh, Whenever we will be working with binary, we will be having a number like 8-bit, we have a number like 12-bit. So right now we are only working on numbers that are 8 bits. So that means that if I want to convert this binary number into a denary number, इस बाइनरी नंबर को मुझे डेनरी में कन्वर्ट करना है, बेस 2 से जाना है बेस 10 के अंदर. So let me write it right here as well. This is the first question. This is the first conversion. The number is 11000011. I want to convert this into base 10. So the first thing that I'm going to do right here is that I'm going to write a series for the conversion from binary to denary. और वो सीरीज मेरे पास कहाँ से आ रही है? वो सीरीज मेरे पास आ रही है बेस 2 की प्रोग्रेशन से. जैसे कि मैंने कल की क्लास में आपको समझाया था कि बेस नंबर हम अपने पास रेफर कराते हैं किसी भी वैल्यू को जिसमें जिसके नंबर्स मिलके वो बनता है. तो इसका जो टेबल बनता है वो आपके पास बनता है 2:0, 2:1, 2:2, 2:3, 2:4, 2:5, 2:6, 2:7. आपके पास इस तरीके से बेटा ये पूरा टेबल बनेगा. और इसके बाद इसकी जो वैल्यूज हैं वो आपके पास यहाँ पर आएंगी कि 2:1, 2, 4, 8, 16, 32, 64, 128. ये सारी वैल्यूज आपके पास आ गई. इसके बाद आपने करना यह है कि ये जो नंबर है आपके पास जो ऊपर दिया हुआ है, इस नंबर को एज इट इज यहाँ आपने कॉपी कर देना है. तो ये सिर्फ मैंने आपको समझाया हुआ है. You don't have to necessarily write all of this, right? Like 2 to the power 0 and then calculating them. You can even start it directly from right here, right? Like you can just write the series that is 1, 2, 4, 8, 60, 64, 32, 122, and you can go on for your question. So you are going to write this question right here. This is going to be 1, 1, 0, 0, 0, 0, 1, 1. And as per my last lecture, I discussed with you that computer only uses binary. Why do computer only uses binary? Because they are created of circuits. And now by putting these values, now what I'm going to do is that what is useful to me right now is the value that is only settled as on. So I'm going to use this value, I'm going to use this value, and I'm going to use this value, and I'm going to use this value. These values I'm going to consider, and the ones that are with the zeros, I'm not going to consider them. So this is going to be 128 plus 64 plus 2 plus 1. That means that those values that are turned on, I am taking their this value, right? And those that are 0, I'm not considering them. So for example, if I add all of them, calculators are not allowed. So if I add all of them, it becomes right like 128 plus 64 plus 2 plus 1. 128 plus 64 plus 2 plus 1. It becomes 195. So this is your answer from binary to denary. Do you have any queries in this?
No, sir.
Second conversion that we will be discussing is that if I want to convert from a decimal number to a binary number, that means that now I wish to convert from base 10 to base 2. And similarly, if I have a question, right, like for example, if I have a question like, right, 87 of decimal, and I want to convert that into a binary number. So what I will be doing is that first of all, I'm going to create the same series that is going to be 1, 2, 4, 8, 16, 32, 64, 128. And then just after the series, now I'm going to do the reverse of that, right? Like for example, into the first of the example, I was discuss. I just simply copy paste the number and I add all of the numbers together. But right here, I'm going to do the reverse of that, right? Like for example, I'm going to only put one on the values that makes up a total sum of 87. I am only going to put the value of 1 only on those numbers that are going to make up a sum of 87. For example, if it is 128, should I take it or not? No, I should not take it because the number exceeds. The number I want right here is 87. This is going to be 0. Then, so I have the number 64. So should I take this number or not? The number is less than 87. Yes, I should take it. So I have 64 plus now. I need some other numbers to add together that makes a total sum of 87. So should I take 32? So if I just simply add 64 plus 32, it is giving me 96. 96 is greater than 87, and the answer that is getting greater, I'm not going to consider it. So this is again going to be 0. So should I take 64 plus 16? So 64 plus 16 is basically, I think it's 80. 64 plus 16 makes it 80. So yes, now I'm near to the answer. I only need seven numbers more for that. So I need seven. So this is it. This is going to be 0. Now for having the seven numbers, what I'm going to do is that I'm going to turn all of these on. So 4, 5, 6, 7. So that means that if I add these values, if I add 64, 16 plus 4 plus 2 plus 1, it will result to be in the answer of 87, and hence through this way my final answer of binary is also generated. That means 0 1 0 1 0 1 1 1 is going to be considered as the answer of your binary with a base 2. So do you have any confusions in this?
No, sir.
Now, let's take another example. So, for example, if I have another number, I have a number 101 of decimal and I want to convert it back into a binary number. I have a decimal number that is 101 and I want to convert it into a binary of 2. So, again, what I'm going to do is that I'm going to take a series of 1, 2, 4, 8, 16, 32, 64, 128. Now, what I need right now is 101. So should I be taking 128? No, I should not be taking it because it is a number greater than that. Should I be taking 64? Yes, I will be taking. You need to remember that for solving these types of questions, you always need to start from the left hand side. The right hand side is job 1 and the left hand side is 121. So I have taken 120. I have not taken 128 because it is a number greater than that of desired value. I have taken 64. So which number should I add that makes up 101? I'm going to check it one by one. So if I take 64 plus 32, that is going to give me 96. So yes, the number is near. If I add 64 and 32, it is going to give me 96. And what I need is 101. So 96, 97, 98, 99, 101. I need four numbers more. So this is simple. I do not need this. I do not need this. I'm just going to take this number and 0 and 0. So that's pretty simple. If I add these values, 64 plus 32 plus 4, it gives me the final answer of 101. And hence the final answer of 101 into binary is this. So 0, 1, 1, 0, 0, 100. This is the answer. Do you have any confusion still here?
No, sir.
So right now we have completed two of the conversions. I have already taught you that how you can convert a binary number into a decimal, and similarly how you can convert a decimal number into a binary. That means that we are converting from base 2 to base 10, and similarly from base 10 to base 2. We have completed both of these. Now, moving on to the third area. that is your conversion from hexadecimals to binary. And I hope that you quite remember that I explained to you that what are these hexadecimal numbers. So hexadecimal numbers are basically a combination of letters and numbers. You have seen it yesterday. I discussed with you that hexadecimals gave you an example of MAC addresses. Hexadecimals are some examples of your color codes or HTML codes, like right, like error F7, right, like error E404. So whenever you have in errors a combination of letters and numbers, that is going to be considered as hexadecimal. And the speciality of hexadecimal is that it has the numbers from 0 till 9, and then 10 is considered as A, 11 is considered as B, and 12 is considered as C, and so on. Right? Like, for example, 0 till 9 are going to be same, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 10 is going to be considered as A, 11 is going to be considered as B, 12 is going to be considered as C, 13 is going to be considered as D, 14 is considered as E, 15 is considered as F. These are the lists. So, for example, if I have a question that if I want to convert a number that is F7 base 16 into binary. So how am I going to do that? So for solving this question, the first thing that I am going to do right now is that I am going to split the question into two areas. I mean, like, for example, F is going to be right like this, 7 is going to be right like this, and I am going to split this into two sections. This is going to be your step one. Now, just after splitting it, what you need to do into your second step, you need to write the series. The series is going to be 1, 2, 4, 8. 1, 2, 4, 8. This is the series. Now, the number that is right here is F, and F is considered as 15. So as per this series, I need to make a 15 out of this F. So if I want to make it, I need to turn on all of those values. So this is going to be 1, 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 because 8, 9, 10, 11, 12, 13, 14, 15, right? And for 7, I'm not going to consider this 8. This is going to be 0. This is going to be 4, 5, 6, 7. So you see that your final answer is right here, which is 1, 1, 1, 1, 0, 1, 1, and 1 with base 2. Do you have any queries in this?
Sir, can you explain the F part again?
Hmm.
Sir, F part, can you explain it again?
F part. Beta, in hexadecimals, I have the series such as 0 till 9, and then 10 is considered as A, 11 is considered as B, 12 is considered as C, 13 is considered as D, 14 is considered as E, and 15 is considered as F. 15 is considered as F. So, in your exam, if you have a number such as 15, so you need to write this series, which is 1, 2, 4, 8, and you need to enter 1 only on those areas that makes up the value of 15. The value of 15 right here is, sorry, the value of F right here is 15 as per the table, as per the series. And if I want to have 15 out of these four values, which is 1, 2, 4, 8, I need to turn all of them on. On means I need to put 1 on all of them. So this is the reason I have settled them as 1. So 1, 1, 1, 1. This is going to be an F. समझ आया?
जी सर, आ गया समझ.
So let's work on another example so that your concepts are all cleared. So for example, if I have another number such as F04, this is a hexadecimal number, and you want to convert this into a binary. So what you are going to do is, again, you are going to split this into three sections. F is 0, 4, like this, and then you are going to enter the values right like here. So you are going to give the placeholder values. The placeholder values are 1, 2, 4, 8. 1, 2, 4, 8. 1, 2, 4, 8. By the way, do you understand that why I'm taking the value only 1 to 4 it? You need to understand that if I add all of them, it gives me 15. And if I count all of the values from 0 till 15, it is considered as base 16. This is the reason I'm taking these four values. Now, if this is an f, the value of f is 15. So for making 15, 8, 9, 10, 11, 12, 13, 14, 15. This is it. If I add all of these values, it makes up an f 0. 0 means that I'm going to take all of these values as 0. And 4 is going to be simple. 8 is going to be 0, 4 is going to be 1, the rest of them is going to be 0. So the final answer of this question is 1, 1, 1, 1, 0, 0, 0, 0, and 0, 1, 0, 0. Any confusion in this?
No, sir.
So binary to decimal is done, decimal to binary is also done, hexadecimal to binary is also done. Now let's work on if you want to convert the value from a binary to hexadecimal. That means that I am converting from base 2 to base 16. I am converting from base 2 to base 16. So for example, if I have a binary number and that binary number is like 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 0. I want to convert from base 2 directly to base 16. So perhaps what I'm going to do is now you are going to break this question into four sets of two each. You are going to break this into four sets of two each. And how you are going to do that? You're going to write here 1, 1, 0, 1. You're going to write here 1, 1, 1, 0. Four sets of two each. Now we are going to place the placeholder values, which is going to be 1, 2, 4, 8. 1, 2, 4, 8. These are going to be considered as two values. And now you are just going to add all of those values that are turned on or that are settled as 1. So I'm going to add 8, 9, 10, 11, 12, 13. And this is going to be 8, 9, 10, 11, 12, 13, 14. And in hexadecimals, 0 till 9, 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. So 13 is considered as D, 14 is considered as E. So the answer is going to be DE with a base of 16. So do you understand this? How I can convert from binary to hexadecimal?
Yes.
Or let's check on one of the another example. So for example, if I have a number like 1 1 1 1 0 0 1 1, I want to convert from base 2 to base 16. So what I'm going to do is again I'm going to break this into four sets of two each. This is going to be 1 1 1 1. This is going to be 0 0 1 1, and just after that, what I'm going to do is that I'm going to put the placeholder values, which are going to be 1248, which are going to be 1248. Now, you see that 8, 9, 10, 11, 12, 13, 14, 15. This is going to be considered as 15 and 2, 3. This is going to be 3. So 15 is F and 3 is going to remain same. So F3 is going to be the final answer.